Alright, ladies, here are your examples of how to solve equations. I'll do examples without the calculator, that is analytically, and then we're going to have to use the calculator to find things. So example one is super easy. Most of you won't even show any work when you do this. You can certainly can if you want to show whatever steps you have showed, multiply answer, simple linear equation. Second one's a little more complicated. Most of you probably look at this problem and decide to cross multiply. It's a perfectly good way to work the problem. Just make sure that you show enough work so that you don't make any careless mistakes. And there's our answer. It's equals 7 votes. Okay. The third one, there are two different processes that you can use to solve this one. The first one I'm going to show you takes you to cross multiply not them, and then I'm going to show it to you anyway so you'll do it correctly. You're going to move the 3/5 other side of the equation by adding it to both sides. And I hope you can look at this and see that it's exactly the same problem as example number 2. And so you would proceed in the same way with cross multiplying and solving your linear equation. This will work. However, we are going to see some examples of problems where that will not be the best way to work this problem, to work a problem that looks sort of like this. And so the way I want you to focus on, the way I want you to practice, is to solve by getting a common denominator. And so that looks like this. You're going to get a common denominator for z plus 1 and 5, and that is 5 times z plus 1. Then you're going to get your numerators, z plus 1 times 5, so 2 times 5 is 10. And then 5 times z plus 1, so 3 times z plus 1. And we're getting a common denominator. Simplify your numerator. Generally, we do not multiply out our denominators here. There's lots of reasons for that will come up later on. And continue to simplify your numerator. Again, leave the denominator alone. Once you get a single fraction, one numerator over one denominator, you can think of it like this. If you have a fraction that's equal to 0, and it's just a numerator and a denominator, the only way that can be true is if the numerator equals 0. So we're going to use that idea to finish this problem up. The numerator here is 7 minus 3z. That has to equal 0. You can see we get the same answer that we did when we worked example number 2, z equals 7 thirds. So while either way is acceptable in this case, there will be many cases where solving by the common denominator method is going to be the only way to get the answer. So I want you to start practicing it right now on every opportunity that you get. Okay? All right, I'm going to go back and take a look at how to solve these problems with your calculator. So let's see, I'm going to take a look at this equation. You would never solve this one on a calculator. It's just way too easy to do analytically. But what you generally do is you take the left side of the equation and you put it into y1. And you take the right side of the equation and you put it into y2 on your calculator. And I usually recommend start with M6, although sometimes that's not going to be an appropriate thing to do. And if you have the new calculators in pretty colors, they take longer to graph, but there you go. And what I would expect you to do on your work is I would expect to see a reasonable sketch that looks sort of similar to what your calculator says, labeled with y1 and y2, something like that. Okay? And then to find the actual solution, you want to find this point of intersection right here. There, so that is second trace or calc. And number 5, if it's twist or intersect, notice that it asks you a question, first curve. You want to make sure that the first curve is y1 and say yes or enter. And then it asks second curve, make sure it says y2 and enter. And then it asks you to make a guess. And that you will generally get a faster answer if you just get a little bit closer to the point of intersection. You don't have to be right on it and hit enter. And there you go, there's your solution. The intersection is x equals 1.66666 repeating, and y equals 7, and the x value is the one that you want. Now, in the AP calculus, they will accept answers that are accurate out to 3 decimal places. So for this, you can give the answer 1.666 or 1.667. Or, if you go back to the home screen, second click, the calculator has stored that value in X. It was an X answer, so it is stored it in X. So go to the X and hit enter, and you should get that number, 1.6666. Most of the time, if you do a math one, it'll change it into a fraction. If it is, in fact, a rational number, every once in a while it does not manage to do that. But most of the time it will. So there's your work right here, and there's your point of intersection, which you could label if it says show a well-labeled graph. And the answer again is x equals 5/3. Okay? We'll try this for example 2 and see what that looks like on the calculator. So on example 2, it's the screen. On example 2, you would let y1 would be 2 over x plus 1, and y2 would be 3/5. Let's take a look at how that looks. Calculator. Make sure that you use your parentheses correctly. You can type in the parentheses correctly, and I think our 216 is so we can get to this. So there is that rational function there. And there's that horizontal line, and you can see the point of intersection right here, and there. So stepping out, and check the face, calculate, and 5. Make sure that the first curve is on y1, enter. Make sure the second curve is on y2, enter. And then get kind of close to it. You might remember that sometimes there's more than one solution, in which case you have to get close to the one that you want. 2.33333. I'm going to take that back to the home screen, second click, X, enter, and math 1. We need the fraction answer, 7/3. And I've already forgotten what the 7/3 street is. So back to what you would show on the paper, you would show that sketch, which looks sort of like this, here, and here. And then there was a second line across here, and there's your point of intersection. And then solution was 7/3, 3/5, and our answer is 7/3. Okay? You just need to get practice at finding the window that you want for each of these things. Sometimes you want to think a little bit so you can look at that. Okay. This one, we know the answer to number 3 is the same as for number 2, but I'm going to look at a slightly different method. I'm going to let y1 equal, I'm going to use x instead of z, the left side, and I'm not going to put a y2 in. Y2 is 0. Okay, so I'm not going to bother putting that in. And let's take a look at how we use the calculator to solve this one. And you got to make sure that you're being careful about your use of parentheses here. So I'm going to put in 1. Oops, I've done that one wrong. All right, 2 over x plus 1 minus 2. And I'm going to do the graph for this. And this time, I'm not looking at where 2 things intersect. Instead, I'm looking for where does y1 equal 0. You can see I had that circle there left in the last graph. It's right in that same spot. So the buttons for that are, again, calculate, second count, second trace. But this time we're not going to do number 5, we're going to do number 2, the 0. And this time it asks you to do the left and the right bound, not above and below, but come to some point that is left. You're looking for it in here, so you come to some point that is to the left and hit enter. And then it asks you to move to the right, so you need to move past it. You can also type in some numbers if you want to. It's being difficult for me. I'm going to type in I'm going to type in, I can see that it doesn't go all the way up to 4, so I'm just going to type in 4 and hit enter instead of moving all the way across it. And then it says type a guess. It looks like it's kind of close to 2, so I'm going to type in a 2 for my guess. And when you get to, you get the exact same answer, 2.3333. Okay, so those are the methods for solving equations analytically and with your graphing calculator. You should be proficient at both ways. You should be able to show what those graphs look like. Excuse me. This one would look like this, and then right here we labeled it 7 volts. Okay. All right, I'm going to flip over to the other side so we can get staff take a break. This is a good time to do it. Okay. The second thing is to solve inequalities without using a calculator. That's analytically. And specifically the method of interval testing. This is an extremely important method in this class, and so we want to get some practice with it right now. Okay, so first I'm going to solve it without the calculator, just analytically. Okay, step number 1 is to solve the related equation. So your brain is going to think this step. It's actually kind of nice if you write it, but you just think it, and you find the 2 zeros for the problem. These are the 2 places that equal 0. These are your critical values, the places that are important, where things change. You draw a number line. You put those 2 critical values on the number line, and then you test a value in each of the intervals that is determined by these critical values. So you test some number to the left of -4, for example, test -5. You could test anything, -6, -10, or -100. You plug it in here, and you just think about whether it's positive or negative. -5 plus 4 is negative. Then you plug it in here, -5 minus 6 is also negative, and a negative times a negative is a positive. It's called interval testing. And you test a number in between -4 and 6. Nice number is 0. You plug in 0 here. 0 plus 4 is positive. 0 minus 6 is negative, and a positive times a negative is a negative. You do not have to show all of this work. This that I'm erasing right now can be done in your head. That's all right, as long as you get it right. So on the last one over here, you might test something like 7, 8, 9, or 10. Plus 4 is a positive, minus 6 is also positive, and positive times positive is positive. Then you can use this number line with these intervals to answer the question, when is this function greater than or equal to 0? And that's going to be here and here. So your solution would be when x is less than or equal to -4, or x is greater than or equal to 6. You also might want to remember the interval notation for this. Okay, also an acceptable way to write your final answer. I always forget to put it in there to do. Okay, so let's just go on and roll the next 2 columns the same way, get interval testing under our belts. All right, what are our critical numbers here? They're going to be where x equals 0, and where x plus 2 equals 0. So there's one critical number, and the second critical number is -2. Make sure you put them on the number line correctly. I didn't put them backwards. And then you want to test the values in between them. So -3 here is a negative. I don't care what you put in here. When you add 2 to it and square it, it's always going to turn out to be positive. So negative times positive is negative. I'm going to plug in a number like -1. Again, negative times positive is negative. And plug in a number like 1, 2, or 3, and positive times positive is positive. I am now looking for where is this function greater than 0, and that's going to be everywhere that x is greater than 0, right? Okay, or in interval notation, 0 is becoming. All right? The last one, interval notation testing, is not, it does work if you leave the equation like this or the inequality like this, but it's hard. So this is one of the cases where it's easier to move everything over to one side, right? And it's much, 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 much easier if you will get a common denominator. And then clean up that numerator just a little bit. And I'm going to write that this way. And then you need to factor that. It's quadratic. I'm backwards factoring because I can handle it. I'm going to factor this. My x's go over here. They're negative, so one's plus and one's minus. And I have to get a negative 1 x in the middle, so I think it's going to be a 2, and a 3 here and a 2 here. Just double check, multiply that out, FOIL that out, and make sure that that gives you the right answer. Okay? So now, my interval has to have two numbers on it. It's got to have the number from this, right here, which is going to be negative 3, and for this, which is going to be 2. And then there's a hidden one, and that is the denominator. Any place where the denominator equals 0 is also a place where things might change. Remember, on graphs, those are asymptotes. Usually, not always, but that's going to be where x equals 0 for that denominator. So this time, instead of just having 3 intervals, I have 1, 2, 3, 4 intervals, and I need to test something in each one of those intervals. And to test it, the easiest place to test is in this factored form. So negative 4 plus 3 is negative, 2 minus negative 4 is positive, and 3 times negative 4 is negative. Negative times positive divided by negative is positive. You need to do that for each one of these intervals. So I don't want to skip over this because this is so important. You're going to check something like negative 1. 3 plus negative 1 is positive. 2 minus negative 1 is positive. And 3 times negative 1 is negative. Positive times positive divided by negative is negative. Next section, probably test 1. 3 plus 1 is positive. 2 minus 1 is positive. 3 times 1 is positive. So it's positive right here. And the last one, something like 3 or 4, and that's going to give us a positive here, and a negative here, and a positive here, and we get a negative right there. Okay, so we are looking. I moved everything over. I put a 1 there. I am so sorry. I'm not going to go back and fix this. I moved everything over. This should be a 0. Please take a minute and go back and fix that in your notes. Right there. We're looking for where this, we're looking for this one right now. This is the one we're solving. The solution to this is the same as the solution to this. They have the same solution. So we're looking for where this is less than or equal to 0. And we have two sections here. This one in the middle and this one over here on the end. And so our two answers are in between negative 3 and 0. Negative 3 is inclusive. We've got this equals here. The 0 is not inclusive because that's that place where it's undefined, so it's not inclusive. And then we also have out here on the end, which is 2, x is greater than or equal to 2. And in interval notation, we look like this. And there are our two answers. All right, I'm going to go back up to the top now. I'm going to work these three columns using the graphing calculator to help determine these solutions. All right. On the first problem, what it is, you want to take the left side, put it in y1. You're looking for where this equation is greater than or equal to 0, and that means you're looking for where it is above the x-axis. Okay? Here's my first equation. Put it on the x here. I'll put it on more problems. Okay, graph. There's your graph. You want to get a sketch of this graph. Don't worry about that at the bottom. You know this is a parabola, so you can just sketch that parabola in. You are looking for where this graph is above, greater than or equal to 0, above the x-axis. So you're looking at this section and this section. You need to find this number, and you need to find that number. Those are the zeros of the graph. So I'm just going to find one of them for right now, so I can count, number 2. And I'm going to go over and find, I don't know where my cursor is. It's not showing up on my screen very well. I want to find, get my cursor over here close to this point right here. So I can see 2, 3, 4, 5, 6. It looks like it's 6, but let's just get close to 6, but be to the left, but I'm going to type 5. And you see it jumps over. You don't have to use those the arrow every time. Then I'm going to jump over and say on the right-hand side would be that 7. Okay, and then you can guess anything you want in the middle. Like I said, I think it's 6, but let's just say I guessed 5.5, and it will get you to the right place in x equals 6. Okay, you do the same thing to find this one. And when you sketch these on your paper, then you want to label these two things on your sketch right here. And then you just take the pencil and sort of circle or shade in the region that you are interested in. So the graph would look something like this. You sketch it out like this. You would label the two interesting points, and then either color or circle or something showing where the answer is. And this gives you the exact same answer that our other one did. All of the values, x is less than or equal to -4, or x is greater than or equal to 6. Okay? Take a look at this next one here. Make sure you are careful when you type things in. Don't get wrong answers if you don't have to incorrectly. Right? Okay. Here's our sketch. And you are looking at this case, where is it greater than 0? Again, you're trying to figure out this right here. So you need to check. I know that it looks like it's 0, but you need to double check that it is in fact. So don't just assume it is. It could be 0.1 or 0.0002. So just make sure that you go in and you do your second count 0. You get on the left side, you move to the right side, you move close to it, and make sure that they share. Also a reminder that sometimes the calculator uses these numbers like C -10, like 7.4, C -10. Remember that that's just a way of saying it's getting really, really close to 0 if it isn't calculated. Okay? And so once again, we found that this is 0, so the answer is for x is greater than 0. All right? When we get to the last one, because it's got two ways to solve it, and when we get to this last one here, okay, you can solve this either, let me get a little space for just a second. You can solve this either by putting in a y1 and a y2, like it's written. This will work most of the time. It works okay. So you'd say y1 equals 2 over x, and then you'd say y2 equals x plus 1 over 3. And then what you want to look at is where is the graph of y1 below the graph of y2. Now, while this will work, if the graphs get fairly complicated, it can be kind of hard to see. So I don't necessarily recommend this way. If you do it this way and you get it right, I will certainly give you full credit for it. So I am going to show it to you just so you've seen it, see what it looks like. As long as it works, there's nothing wrong with it. It's just that it's not always easy to see. The other way is more often easy to see. Now, this one shouldn't be too bad because what we have is here's the rational function, and then you have a line. So this one's not too bad, okay? So our y1 came out blue and our y2 is red. I'm looking for the region where the y1 is below the y2. And so that's this region right here. So this is going to be for x, so I need this number right here, and then over to 0, okay? And then I need this region right here that I just colored in, everything past that number. In this case, you're going to look for points of intersection again. I'm going to once again just find one in the interest of time. Second count. Maybe. Yeah. And I'm going to I'm going to find a point of intersection. And I'm going to jump over here. Make sure you're going to the one you want. I'm going to jump over here and do this one. Get close to that. So it looks like it's around 2. So I would say to the left of 2 is maybe negative 1.5. Just put in anything, not negative 15. That's not going to work. Let me get that number. Second, out. Finish that. Negative 1.5. Here we go. Okay, second layer again. Oh, I'm sorry. This is first curve, second curve. I apologize. So first curve is on y1, and second curve. Right, I obviously had a total rate graphing calculator, but this is the same as the point of intersection the first time around. So I apologize again. When you find point of intersection here, you're going to find that this number here is 2, and this number is -3, and then you need to describe that graphically with the x values. This is x values between -3 and 0. -3 and 0. It includes the -3, not the 0, because it's an asymptote. And then it's the numbers from 2 to infinity, and it includes the 2. And you don't include infinity because infinity is not a number, it's just a concept. All right, hopefully when I come back to this in a minute, it will behave a little bit better. Okay, so that's one way to do it. The second way to do it, which I think is a little more, it works better this way when the graphs are complicated, is just move everything to the left side and make sure you put equal 0 there, not equal 1 like I did on the other problem. And graph this as y1 and look for where it is below the axis. So take a minute and get this into your y1 and take a look at it. You can hit pause. When you've got it ready, just start it over again. All right, and you should have a graph that looks something like this. Okay. You are looking for where this graph is below the x-axis. And so that's this section right here and this section right here. So you're looking for that number and that number. This time you're going to be finding the zeros. Once again, you're going to get that this one is -3 and this one is 2. And so once again, you're going between -3 and the x value here is 0. Okay, so that's an asymptote, so non-inclusive, and inclusive because of this right here. And then 2 out forever and ever. Okay, so there are your examples for how to solve equations and inequalities analytically as well as graphically.